My name is Madhusika Vimalaratna. I'm a PhD student in University of Alabama in Huntsville. In recent decades, aging-induced metabolic syndrome has become a public health problem throughout the world. Studying metabolic changes related to aging and diet-induced disease pathogenesis in humans has limitation. So, studying animal models that mimic human pathological condition can expand the current knowledge on age-related metabolic dysfunction. Our rat model is Live1WRR rats. The specialty of this rat group is that they are overexpressing fattin genes in liver, which help to understand the liver fattin role in disease pathology. Now, why fattin genes? It known to be that suppressing the fattin genes can improve the age-associated metabolic dysfunctions and insulin sensitivity and longevity. So we hypothesize that Live1WRR rats develop markers of increased insulin resistance and increased liver fat as a product of developing excess body mass in response to either aging or moderate sucrose diet. What we observe in this experiment is rats didn't show significant changes due to diet but due to strains. We observe significantly increased liver masses in 1WR1 control rats and 1WR1 moderate sucrose diet rats compared to Westerford control rats and Westerford moderate sucrose diet rats. So from now on, I'm focusing on Westerford controls and 1WR1 control rat groups since we didn't observe any significant changes due to the diets. We did insulin tolerance test at age of 6 and age of 16 weeks. We gave them bolus of insulin and look at the insulin response. 1WR rats have increased area under the curve at age of week 6 and age of week 16 compared to the Westerford rats, and that gap between the two groups becoming larger with age. That's mean 1WR rats becoming more and more insulin resistant with age. Insulin resistance can alter the glucose and lipid metabolism, and excess glucose can store as lipids in tissues. So, when we did the triglyceride assay, we didn't observe significant difference in triglyceride levels in blood, but we saw significantly increased triglyceride levels in liver in 1WR1 rats compared to the Westerford control rats. And also, we observe significant increased triglyceride levels in muscles in 1WR1 rats compared to the Westerford rats. So we assume that excess fat can deposit in liver, which could possibly cause us to the pathological changes in liver in 1WR1 rats. So when I look at the steatosis scoring, we saw 1WR1 rats have significantly increased steatosis compared to the Westerford rats. We can actually observe lipid droplets in hepatocytes in 1WR1 rats compared to the Westerford rats in histology slides. And when we look at the inflammation scores, 1WR1 rats have significantly lower inflammation scores compared to the Westerford inflammation scores. That because we assume 1WRR rats already passed the inflammation stage and now they are stepping into the liver fibrosis stage. We didn't observe high inflammation at this stage. At last, we look at the liver ballooning in 1WR1 and Westerford control rats. What we observe is 1WR1 rats have elevated liver ballooning compared to the Westerford controls. In conclusion, 1WR1 rats develop reduced insulin sensitivity and start accumulation of lipid in liver with age. That causes to increased liver injury, ballooning, and steatosis in hepatocytes that indicate these rats are not only develop fatty liver but also predisposed to develop non-alcoholic fatty liver disease.